So observe very carefully. We all know that gravity of Earth and gravity of Moon. What is the relation, everybody? Gravity of Earth is equals to, please. Gravity of Earth is equals to 6 times of gravity of Moon. Am I right, everyone? Yes, Sanjay? All of you? Or else we'll say gravity acceleration due to gravity on Moon is 1 by 6 times, or it is 6 times less than the gravitational force on Earth. Next, as we know, weight of the body is directly proportional to acceleration due to gravity, because we have studied that. What is the weight formula, all of you? What is the weight formula? Mass into acceleration. Understanding? Mass into acceleration due to gravity. Yes. So weight is directly proportional to acceleration due to gravity. So that's what I'm saying. Weight on Earth is equals to also 6 times of weight on Moon. Do you understand, everybody? Or weight on Moon is equals to 1 by 6 times of weight on Earth. This is the relations between weight and as well as gravity, acceleration due to gravity between the Moon and the Earth. This is what we studied. Am I right, everybody? Good morning, Arashani. Good morning, Sanjay. Good morning, everybody. Yes, please. So that is what we have been done. Am I right, guys? Now, recently, our India has been successfully launched a satellite. What is the satellite, everyone? Yes, please. I love you. Chandrayaan-3. Am I right or wrong? So now, you can see, suppose, if this is the Earth and this is the Moon, now there is an object which is falling from the certain height, h. Both height is same. On the surface of the Earth and the surface of the Moon, height is same. Now my question to you all people is, what about the time period? If it is falling from the same height h, does it time is same in both the cases? Let me take T1 and this is T2. Is it the time period both the cases remains equal or unequal? That is only our thing. Now satellites and all, you can see even Chandrayaan-3 when it is launching, we have been all watched lively. So how it is slowly, what speed it is falling and what way they are reducing and everything we have been watched it. So that is what is basically space technology. This is gravitation chapter only entirely will be working. Without gravitation, there is impossible to even launch a satellite, make a satellite to carry it, and make a satellite to again layering over on another surface. So now as we are familiar with the Earth and as well as Moon always, so if the time taken on Earth to land over something is some t seconds, then what is the time on the Earth? Sorry, Moon. That is what is our question now. So all of you write that question. Understand the question very carefully. Again, give number properly, and everybody give numbers properly. For whomever I have allotted the numbers, give the question numbers properly. Sorry, your numbers. Write the question 1, all of you. Shall we start, everybody? Please respond. Yes. To make it a body released from height. See, this is the most important chapter, even for your future classes, for NEET or JEE, whatever it is. And this is the one of the important, interesting topic also. We'll come to know about many facts, scientific facts about satellites or planets or everything. So a body released from height h takes t seconds or t time, takes t time to reach to reach the earth surface. To reach the earth surface. Kavya, are you there? Yeah. So calculate the time taken by the same body to reach the surface of the moon. Because what is your expectation? Is the time remains same or difference? Anybody? What is your expectation, everybody? Is the time remains same or it is differs? Please respond.
Different.
Different. Why? Why? What makes you feel it is different? Anybody? Because gravity is different. So pulling force is different. Then for that time also different. Am I right, guys?
Yes,
Please
sir.
respond. So pulling force is not same. So that automatically the time is also not same. Is it okay, guys? Everybody? So with that, let us move forward and calculate it. I will teach you, you make attention a lot. So if you have anything doubt, you can ask me so that I will say you later. Okay. So observe here, all of you. They are saying that at Earth, what is the height given, everybody? So let me take first at Earth, H. Okay. So at Earth, you observe and later you can try. The height H is given by, so what is the H, guys? Of course, any object is falling. So for example, this is the Earth. So we all knows if any object is falling from a certain height, something is zero. Can you tell me, guys, what is a zero?
Initial velocity.
Yes, very good. So H is equals to H and initial velocity is zero. So by this time you understand, and time taken to reach the earth is, I am taking as a t seconds. Okay. So you can use particular equation. By this time something will be there in our mind. I want that equation. Anybody? Yes, please.
This is equal to ut plus
Yes. H is equals to ut plus.
half ut
Everybody has to try. That is what is expecting. So you have to work correct. Please. All of you. H is equals to
ut
ut
plus
plus
half
half
ut
t
plus
square.
half at square. Understanding S equals to ut plus half at square. But as it is free fall, so R is coming down. So we have to replace it what? H is equals to, speak loudly, guys. H is equals
This is
to
equal to ut plus
ut.
half at
ut.
square.
Yes, Mari. Ut plus half G. G means what? G of earth. Purema. G of earth into t square. Now initial velocity is what, guys? Everybody? Initial velocity is 0. So this whole term will become 0. So H is equals to half gravity acceleration due to gravity of earth on t square. Am I right? Will you all agree with me? Everybody? Yes, please. Any doubt? You can ask. Clear? Mare? Understand? Now. So instead of earth, let me take now all of you at the moon. At the moon, the height is given. So the height is given. So let me take instead of the height, instead of h, I am taking as a h dash. So h dash, understanding? And the time taken is t dash. Purima, Elame, understand? Or you take it as this is T1, this is T2, your convenient. Okay. So that is even better for me. You take it as this is T1 square.
Sir, on doubt, sir.
Yes. T1
Sir,
square.
but they asked us to find the time only, sir. But
That's
why
what,
are
Mari.
we?
Wait, Mari. That's what we have to find the relation, Mari. You understand, yeah?
Yes,
Yes.
sir.
Don't worry. Just wait. Understand. And also see, here I have taken H1. Let me take this is H1 and this is H2. But according to the question, what they are saying, H1 is equals to what? H2. Do you understand?
Yes,
Yes
sir.
or no? Height. That's what. For your purpose only I'm taking. And I've taken this is time 2 and initial velocity is 0. Any problem? Any problem? Do you understand? Yes, please. Respond, guys. Everybody. So now, so what will happen here? Again, second equation. So S equals to ut plus half EAT square. So this I am taking H1, and here what will happen? H2. So H2 is equals to initial velocity 0. So half into here G of what? Moon or Earth? G of moon or Earth? Everybody. G of moon and T is equals to T square. Anything doubt, Agalya, in this? You can ask me. Clear, everybody? Please respond, guys. This is equation
Yes, sir.
2 and this is equation 1. So according to the question, we all knows that H1 is equals to H2. Am I right, guys? Speak loudly, everybody. So H1 is equals to H2 means in the sense of H1 is equals to H2. So can I equate it, everybody? Half into acceleration due to gravity of Earth, okay, into T1 square is equals to half into acceleration due to gravity of moon into T2 square. Now something will get cancelled. Observe this both and tell me what you can get cancelled. Agalya?
Half and half.
Yes, very good. Kavya, do you understand? So half and half will get cancelled. Gokul doing next you see. So now you use the relation what you studied in our today's class, morning. All of you. Check it everybody. So in place of gravity of earth, I can do something. What I can do? Anybody? Gravity of earth. In place of gravity of earth, what I can write, guys? Gravity of yeah, because they're asking moon's time. Am I right? Understand, Gokul? So they're asking moon's time. So in place of gravity of Earth, can I write it as a 6 times of gravity of moon into T1 square is equals to gravity of moon into T2 square. Any problem for anybody? You can ask me. Are you clear, everybody? So gravity of moon and gravity of moon will get cancelled. Here you can see we want T2, that is what? Time on moon. So T2 square is equals to 6 times of T1 square. Square will come this side, it will become root. So root 6 into T1 square. This I will write it as a separately root 6 into root T1 square, which is equals to root 6 into square and root will get cancelled into T1. So this is what it is. So if observe very carefully, the question is, for example, I am dropping a ball from certain height on the earth. Okay, all of you observe. In the earth, it will take, for example, 10 seconds. Then on the moon, it will take how many seconds? Anybody can tell? On the moon surface, same height h. It will take how many seconds? Everybody. Root 6 into 10, which is equals to, that's what, T1. That is a formula, which is equals to 10 root 6 seconds. Understand, Sam? Google? Yes? That is what. Understand, Amma? Yeah. So, very good, Lingesh. Lingesh form the relation immediately. You can see the message, direct message. You can send it group message, Lingesh. Time is inversely proportional to gravity. Do you understand, everyone? Am I right or wrong? So gravity increases, the landing period, the time taken to reach the surface is less. If the gravity is less, the time taken to reach the surface of the ground, whatever surface is more. So that is the smartness you have to observe. So this is the formula, not only you, everybody will use. Understanding? And
Sir, on doubt, sir.
yes, every
How did you
scientist.
find that T1 is equal to 10 seconds, sir?
T1 already I have given, Mari. That's what I'm saying. For example, this is the earth. I have found, for example, I dropped from 100 meters height. Purima, 100 meters
Yes,
height. I calculated that it is because we are living on the surface of the earth. So I observed that it is taking 10 seconds to reach the ground. Do you understanding? Example, I'm saying. You
yes, sir.
understanding? Then moon you cannot go. You are not there in the moon. Then Once the satellite will reach us to the same height above from the moon, you can see like Chandrayaan 3. They have been controlled the speed. Have you remember every level coming down?
Yes,
Coming down?
boost this.
Yeah, that they will calculate before itself. Simply namesake they cannot do. It will collapse. So the same height when it will comes to the earth, you can see. Then the time taken to landing is √2 times of T1. So that is what T1 means, time taken to land on the earth. So that is what, like that they'll calculate it, then according to that only speed will be adjusted. That is what I'm saying. Do you understand? Clear?
Yes, sir.
Yeah. Anybody having any doubt in this, you can ask me. Sangamitrai, Alfin, now only joining. Okay. So nothing is there question. So you can, it's very beautiful question. If it will take certain seconds or certain time period to land object from a certain height from the on the ground, then what is the time taken on the moon? They are asking. Anybody having any doubt in this, you can ask me. So this is one of the a very good question where you can experience it little more like what we can say is conceptual knowledge is very needed. Any doubt you can ask me or else we'll proceed further. Arasani understand? Gokul, Hasani Sudhaka, Hasani, do it. Pradav, clear Pradav?
Yes, sir.
Again, based on this one.
Yes. Anyone having any doubt, you can ask. A small doubt also, unless you open your mouth, nothing is going to change. You should ask, and you have doubt means you ask. I am ready to explain. That's not, you all people knows me very well. If you are having a doubt, definitely 10 times also I'll explain. You have to work, okay? Any doubt? Can we go to the next question? Everybody?
Yes, sir.
Again, based.
Yes, yes. Okay. Now, next beautiful question. This is, see that, all of you. If you have noticed it, everybody, basically, Earth is not a spherical in shape. We have studied that. What do we study, Lingesh? Anybody tell me? Yeah. At the poles, radius is less. Radius at the poles is less. Radius at the equator is greater. That is what? Radius at the equator is greater than radius at the poles. But what about the gravitational force at the poles? Everybody? Gravitational force at the poles, which is greater? At the equator or at the poles? Yes, please. At the poles. Understanding? Radius is less, but gravitational force is more. Gravitational force of attraction at poles is greater than gravitational force at equator. Am I right, guys? Please respond, all of you. Because we all knows that G formula, capital G into capital M divided by R square. Note it, everybody. If R increases, because it is a denominator. So what is the relationship between G and R? Pakranga, everybody. What is the G and R relation? Inversely proportional to square of radius. Understand, Ra? Respond. So if R increases, G value decreases. G value decreases. Ellame okay? Please respond. All of you? Yes. Nivedan?
Yes, sir.
Yeah. So now, we all knows this. Just now we studied that gravity increases, landing period is more or less. Everybody, moon and earth if you compare. Gravity increases, landing period will be less or more? Everybody? Yes, please. Gravity more, the time taken to land on the surface will be less. Gravity less, the time taken to land on the surface will be more. Am I right, guys? Please respond. Now, we have to prove mathematically. The next question is, if you take on the surface of the earth and surface of moon, what is the time taken to land over the object? Because we all know gravity of earth is not uniform throughout the body. At the poles, as a radius is less, so gravity will be more. At the pole, at the equator, radius is more, so that the gravity will be less. Am I right? No interest, no use. Clear, everybody? Understanding?
Yes.
Now let us see.
Yes, sir.
It is extremely higher order thinking skill. Based upon this small concept, we people are going to make a big question now. So write it, everybody. Are you feeling interesting or not? Numericals. Mr. Lingesh, Kishore, the objects are, yeah. See, don't underestimate. Many people may think why we are need to learn. You have to learn, okay? If you learn, only the things will change. Start thinking with your mind, then only you can do it. Write it now. Gokul, are you trying, Gokul? Two objects are dropped from the, yeah, dropped from the, very simple only, Gokul. It will looks very tough, but the thing is, the concept, if you understand, there is no difficulty at all in this. So if you are not really cheating, it is not at all a thing for you at all. That's what my opinion. Mr. Mugesh also same. Niroshi, have you understand this moon question, Niroshi? Clear?
Yes, sir.
Yeah, very good. So if you are understanding, that's fine. That is all. Okay, let me write this question, everybody. Two objects are dropped from the same height. From the same height, but one object is dropped at polar region, and the other object at the equator. By this time you might understand what will be the question. Am I right, everybody? Yes, that's how it is. At the equator or equatorial region. You can write it, equatorial region. What is the ratio of the, question is, what is the ratio of the, such a beautiful question, you can see that. So what is the ratio of the, now from this you tell me, is the time period is same, where the landing on the poles and the landing at the equator, is the time period is same, everybody?
No, sir.
No. So that is what, even directly I can say you, as the gravity at poles is greater than gravity at equator, so that always time. So gravity more, gravity increases. Time period is what? Decreasing. Both are inversely proportional. Am I right or wrong? Yes, please
Yes,
respond, guys. That is what.
Yes, sir.
So what will happen? Where it will landing the fastly? At the poles or at the equator? Yes, please. Yes. Yes. At the poles reaches faster.
Sir, you have written gravity is directly proportional to time, sir.
Yeah, inversely. Inversely, 1 by. Inversely proportional to time period. Sorry. Okay, everybody. So it will reaches the ground first. Reaches ground faster. Where? At the poles or at the equator? Everybody. Where it will reaches the ground faster? At the poles.
Poles.
Understand? Kavya, Sangamitrai? That is. Now they're asking what is the ratio of the time taken by the two objects to reach the ground. To reach the ground. Any problem for anybody, you can ask me. Are you clear, everybody? If you are okay, then
Yes,
we'll
sir.
proceed. Yes. Okay. Now, So we all know, let certain height, both cases height only. So let us take one is at the poles, another one is, let me write it now. Suppose both the objects are dropped. Both the objects are dropped.
At the same time.
Yeah, from a height h Mari. Time only we have to find it, Mari. Yeah, at the same time also you can. Okay. So to side height h. So now first for the object at the polar region. Any problem for anybody? Object is at where? First polar region. What else next? Second one. Second one is what? Everybody. At the responder at the equator. Okay. So first let us find time period at the poles. So what is the first? Everybody you can see. Let GP is the acceleration due to gravity at poles. Any problem for anybody? Let GP is a what? Everybody? Acceleration due to gravity at where? Speak loudly. Acceleration due to gravity at pole what? Everybody. At the poles. Clear? Now, let me take at the poles. This is the pole, Amma. What not pole or south pole. Any object is falling towards that initial velocity. Ellame. Yes.
Zero.
And S is equals to, let me take H1 and dimension. What dimension, everybody? Asking the time relation. So let me take the time taken to reach on the poles is TP. Any problem, Sanjay, Kishore, Lingesh? Understand? So the time taken to reach at the poles is TP. Distance is H1. Okay, sorry, H1. So which equation I can use it? Anybody tell? Which equation I can use it? S is equals to H1, U is equals to 0, T is equals to TP, and A is equals to GP. Ellame? Which equation, Ra? Very good. So S equals to UT plus half AT square. Ellame understand? Agalya? AT square. So replace it. H1 is equals to initial velocity 0, half into A means what? GP. Gravity acceleration due to gravity at poles. And T means what? Everybody. TP. The time taken to landing on the earth at the poles. Any problem? Yes, please. We want T. So I will write now. TP square is equals to 1 by 2 will come this side. It will become 2H1. GP will come this side by GP. So TP, time at poles to reach, equals to square root of 2GH1 divided by GP. Any problem for anybody? You can ask me. Okay, wow. Yes, please. All of you. That is. So this is what? Equation number 1. So we all know at the same height we are dropping. So H1 is equals to H2 is equals to what? Anybody? H1 is equals to H2 is equals to what? Speak loudly. H. Understand? So let me take presently H1 only. Later. Second, for the object at the equatorial region. So let me take it now. So equatorial region, Earth gravity is EQ. EQ means gravitational force of attraction at equator. Next, G is equals to EQ. That is what? A. Now I'll take time period is equals to TQ. Time is equals to TQ. Next one, S is equals to H2, which is equals to H only. And again here also, at the equator also, doesn't matter. So body falling from certain height. Initial velocity is what? Everybody? Initial velocity is what? 0. Purima. So initial velocity is 0. Again, which equation? Second equation. S equals to UT plus half AT square. Yes, will you all agree with me, guys?
Yes, sir.
Yes. Now you can take it, everybody. S is equals to H2, which is equals to initial velocity 0, half into G value. A means what? At G value at equator. T means G value at equator square. So replace it now, everybody. So what will happen, everyone? So your time period at equator square is equals to half will come this side, will come. So H2, 2H2 divided by acceleration due to gravity of at equator. That is what. Now we all knows that this is, let me take equation number 2. So now if you see, we want to find the relation. Am I right, guys? So sorry, it is not root. So time at equator is equals to root over 2H2 divided by acceleration due to gravity at equator. Any problem for anybody? Do you understand? Sanjay, Mari, Lingesh? That is what it is. So now we all know, so let me take this is equation 2. So they're asking a ratio. So ratio of what, everybody? Check it, everyone. What they're asking? Ratio of what? All of you.
Time.
Ratio of what they're asking? What is the ratio of the time taken by the
Time taken.
objects to reach the ground? So your choice. So can I take it time taken at poles and time taken by equator? Any problem for anybody? Ratio, guys. Okay, wow. So what is the time taken at the equator? Sorry, poles. Poles I want it. Anybody? Poles, Pakranga. 2H1 divided by GP. What is that? Root over 2H1 divided by root over GP. Then this one is 2H2 divided by equator. Gravity at equator. Okay. Now, up and down, you can see both. I will write it as a common root. So if I write a common root, 2H1 divided by GP. Next, this one, 2H2 divided by G equator. Now again, we all know at the beginning we have been done. What is that, everybody? What is the H1 and H2 is equals to? H1 is equals to what? Speak loudly. H1 is equals to H2. So that is what. So we know height is same. So H1 is equals to H2 is equals to H. So now you can see, I'll replace it. 2 will get cancelled. Let me reminding, or else you avoid that also. Because let it be very slowly, we'll make it. So all of you observe very carefully. So 2H2. Now reverse it will become. So A by B divided by C by D, which is equals to A by B into D by C. Am I right, guys? Speak, guys. Everybody?
Yes,
that is. So it will turn up into 2H1. I'm replacing H. 2H by GP into G at equator divided by 2H. Any problem? Anybody? You can ask. So both will get cancelled. What is the relation? Root over acceleration due to gravity of Earth divided by, at the equator divided by acceleration due to gravity at poles. So that is the relation between TP and time period at poles and time period at equator. But you all knows, can you tell me who is greater? Time period of equator or time period of gravity? Because we all knows, what do you know? Where the gravity is more? Everybody? Where the gravity is more? At the poles. Poles
The
is
pole.
greater than equator. So time period opposite, reverse, because G is inversely proportional to time period. So what will happen, everybody? At the poles. At the poles, time period is less or more? Yes, please. Time period at the poles.
Yes.
Yes. Time period at the poles is less than time period at equator. So that is what you have to remember. Any problem for anybody, you can ask me. Girls and boys, please respond. So
Then
therefore,
G of poles will go upside and the equator will comes down, sir.
no Mari. Where? Which one?
In the ratio format.
Yeah, ratio format just reverse Mari. It is reciprocal, correct? You can see A by B divided by C by D. I can write as A by B into C, D by C. That's all.
Yes.
Understand? Yeah. Okay, everybody. Clear, ma? Meeting is going to end. Join back. You finish it, then only I'll leave you. Okay. So therefore, write it. Therefore, Alfin, you understand this question? I want response. Therefore, time taken by the object to reach the surface of the earth will be less at the poles. Earth will be less